T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Liftoff of Falcon 9. Go SpaceX, go Cosmo. Vehicle is pitching downrange. Stage 1 propulsion is nominal.
At 2+30 seconds into flight, Falcon 9 has successfully lifted off from Space Launch Complex 4 East at Vandenberg Space Force Base in California. We're currently throttling down to prepare for max Q, the point of maximum aerodynamic stresses on the vehicle. Max Q is reached when the air density of the atmosphere decreases faster than the increasing speed of the rocket.
Falcon 9 is supersonic. Q.
And there you heard max Q. From here on, even though velocity is rapidly increasing, the atmospheric density is decreasing, resulting in less loads on Falcon 9. Now we have several events coming up in quick succession, starting with MECO, stage separation, stage 1 flip, second engine start, or SES-1, the boost back burn, and fairing deploy.
Cutoff. Separation confirmed. Back ignition.
And there you heard and saw those 6 events that happened back to back, including main engine cutoff, stage separation, stage 1 flip, second engine start 1, and the boost back burn and fairing separation. The next major milestone coming up is entry burn on our Falcon 9 first stage, which is scheduled to occur just after the T+6 minute mark.
Confirmed.
The entry burn is used to slow the first stage as it heads towards landing zone 4.
Both vehicles are following nominal trajectories.
We're currently in our first MVAC burn, and this burn should last for another few minutes. The next milestone will be first stage entry burn, coming up in a little over 2 minutes. Today's Falcon 9 is performing 2 burns in order to land. The first burn, known as the entry burn, slows the vehicle down before hitting the denser parts of the Earth's atmosphere. Without this burn, we'd only be using the atmospheric drag to slow down the Falcon 9, which would add extra stress to the vehicle. Following the entry burn, the booster will initiate the landing burn, which should slow the vehicle down even more for a successful landing at Slick 4.
Both vehicles continue to follow nominal trajectories.
When Falcon 9 fires up the center M1D engine for re-entry, the vehicle will be flying through Merlin's exhaust gases, also known as the rocket's plume, which deposit a layer of soot on the vehicle's surface. You'll see these marks across the flight-proven Falcon 9 first stage fleet. That soot comes from a carbon-based fuel that Falcon 9 uses, and with each flight, the soot builds up a little more on the outside of the vehicle. Falcon 9 is equipped with 4 hypersonic grid fins positioned near the top of the first stage that help steer the first stage as it returns to Earth. The white puffs coming off Falcon 9 that you may see on screen are cold nitrogen gas, which helps with altitude control.
Do you want entry burn startup?
And there was the call out for entry burn startup on the Falcon 9 first stage. This burn is set to last about 30 seconds and again is slowing down the vehicle in preparation for its final burn and landing.
Do you want entry burn shutdown?
And that concludes our entry burn. As mentioned earlier, we will be attempting to recover this booster. Today, the booster is targeting a landing
Vehicles continue to follow nominal trajectories.
Today, this booster is targeting a landing at Launch Complex 4 West. You can follow along with the burn on the engine graphic at the bottom of your screen. As the burn happens, you'll notice a decrease in both speed and altitude. And this is coming up in about 20 seconds.
Which one FTS is saved?
One transonic. Stage 1 landing burn.
And there you heard the call out for landing burn start on the Falcon 9 first stage. Again, this is the final burn that this booster will execute before landing.
Stage 1 landing leg deploy.
And as you saw and probably heard, we had a successful first stage landing.